Nicer, nicer, good.
Thank you.
Love your smile. Good, thank you.
I hope everyone is, yeah, it's okay. Okay. Thank you for joining this session. I hope you will learn something useful here and will be enjoying this as much as I. Small reminder, who am I, what I do for a living. So my name is Nowakowski, Tom. I'm a cybersecurity architect, penetration tester at CQURE. In this company, we present every type of security activities for our clients, from penetration tests till audits, code reviews, etc. And we learn a lot from our clients. We gather a lot of useful information techniques. We do a lot of research by ourselves. I will be presenting here a couple of our tools also. So maybe let's just start. First of all, I would like to tell you a little story about one of the penetration tests that I have recently done when there was something unusual in the behavior of the people maintaining the security in the company. Unusual for me, maybe not unusual for someone else. So imagine the situation when every IT administrator is treating his infrastructure, his network, his servers like a family, like a child maybe. So if something bad happens to his infrastructure, then he's very, very disappointed. Because he's disappointed or sad even. So that was the case because I was doing penetration tests, and after about 2 hours I gained access to the core infrastructure service, and after showing that I have full access for the system, the people that actually were responsible for this system, for maintaining the security of the system, were just very sad. So their faces were just like, okay, so we've lost everything. I'm pretty sure that they didn't lose their jobs. So this was something like, okay, so this is the time to sit and learn and maybe review our configuration to find out what was wrong in this scenario, what was wrong in this configuration, and improve it. Yeah. So maybe I will show you some different techniques, different attacks that every time penetration tester is able to use. He is very excited about this. So because, for example, as a security guys, we always want to have something like, let's find something new, let's find something very challenging for us, let's not do the same things over and over again. So I think the best approach for doing this type of activities, this type of services, is to find in our clients, find always something very challenging, and let's say the obvious vulnerabilities, obvious security issues should disappear, or maybe let's not try to repeat them. Yeah. So first, let's say excitement from the perspective of the penetration tester is local firewall. Why is that? Now, after gaining the first access in the workstation or the server, we usually see that there is actually no firewall involved, no local firewall involved. Enterprises, big companies are focusing mainly on their enterprise level firewalls, maybe 2, 3 of them, big machines that are covering all the network, and everybody is looking at them, at these firewalls, the big machines, not the software firewalls on our workstations. What does it mean for us? It means that after gaining the first step, after gaining the first access in the workstation, you can just easily connect to, let's say, other service, either via DNS or via other protocols. And this allows us to easily download files, download malware, and escalate our privileges. Yeah. So this is very simple to mitigate protection mechanism because strictly enabling firewall and adding a couple of rules will do the job. On top of that, we can think about one extra layer, that is, if we know which process is able or is allowed in our configuration, in our environment, to connect to the network. Actually, does Notepad needs to connect to the internet or network? No. Yeah. So this is the rules that we should rethink if implementing local firewalls, because some externally provided firewalls will not have this information. So even if we catch the traffic from the infected machine, we cannot say that the traffic was initiated by this process on this machine. The process was running on this user account. We don't have this information on the network, on the cable level. So doing local firewalls and rules for processes, local processes, will give us this extra information. Yeah. So second thing would be the password, the credentials. Something, let's say, most important here, because as we can imagine, we use passwords every day. I can imagine that some of you use unique passwords for unique services. For each service, the password is strictly unique. It's not a matter of changing some numbers or a couple of letters. The passwords need to be fully unique. But maybe some of you are reusing passwords. If you use one password 2 times for different services, then this can lead to a serious problem. And I will show you the most simple scenario of such a problem of sharing the password, because every time we use our passwords, we need to be aware of one fundamental thing. Only for authentication, the password is stored as a hash, only for that process. If we are doing or using password for any type of configuration for our services, then the password should be stored somewhere in reversible manner, because the service itself needs to gather this password to authenticate to the system and just use this provided identity. So I will show you the scenario when we can create a service, and as a good administrator, we will change the service identity to someone else's identity, and we'll try to find out if the password is safely stored. So for that, let's use Windows 10. That will be a simple case. Yep. Okay, it's visible. I will change maybe a little bit the font size. Okay. Yep. So let's create simple service, Notepad service. let's give it a path for the actual executable. Yep. Okay, that was my mistake. That I need to run this as an administrator with the higher privileges. Okay, let me do it again. Notepad. Survey. Yep. Okay. Let me verify if the service actually is configured. Yep, it is here. So as a good administrator, I know that by default, Windows creates or uses the local system authority. This is the highest, almost highest privilege in the Windows. So I need to lower that to use this, let's say, dedicated account. Let's pretend that this is a dedicated account for that service. So I will provide this account password. Okay. Everything is set up, ready to use. I'm happy to use, let's say, dedicated account or not. I just use my own. I'm lazy. These are the examples of the real-world scenarios. I found several cases when normal user account of some IT guy was used for everyday work, and the password was the same as his elevated account, the account with ADM or another prefix or suffix. So the same guy also used this account, his ADM account, for example, for services that needs to have higher privileges, let's say backup service. Yeah. So this is a serious problem when the service starts by different account and the same different account is reused by real human or other service. Because, for example, right now, I can use one of our tools that will reveal the password. Yeah. So first, let me elevate myself to the system account. I will use ITSEC for that. ITSEC is sysinternal's Microsoft signed executable, specially prepared for running code on local or remote machines. A license said that this shouldn't be used for hacking purposes, but we are not doing hacking here. Yeah, so let's say we want to have a system privilege, interactive console or executable, and this is actually the executable. So we will run this one. I hope it will run because I just cannot hit. Yeah, my enter just flipped. Okay, so this is the system console, and let me go back to the folder with tools. And one of our most important or useful tool is CQURE Secret Dumper, CQURE Secrets Dumper. Actually, it has a lot of different places to look for secrets. One of these places is services. So we can just provide a service name. This was Notepad SVC, as I remember. Yep. Notepad SVC. I'm not sure if that was the case. Notepad SRV. Yep. my mistake. So, as you can see, this is the password for this account, excluding the dots, yeah? So, this is the first trivial example of extracting the password. Why is that? Why is this password revealed in clear text? It should be, yeah? Because Service Manager works this way, that needs to have the password and the account name to use to authenticate against Active Directory, for example, to elevate the process to the identity for particular process, for a particular service, yeah? Let me switch for the server now version, because IIS, very interesting service, very interesting, important service of Windows, yeah. The web server has also different places when it stores his credentials for certificates, for example, to extract the encrypted certificates, as well as for application pool. Let me show you this here. Application pools. Application pool is something like what will this let's say thing, this container actually is responsible for getting the request from the web browser and putting it to the backend server or the actual process to get the response. And this pool will have to have identity for different use. For example, for having access for different folders, etc. Yeah. So let's say we want to change the default pool identity for someone else's identity. This is a default identity. And again, let's use our rob shift ADM account for that case. So we are preparing default configuration. We have changed the identity for the application pool. We are ready to set. We are confident that from the perspective of configuration of IIS web server, everything is set up correctly. But if someone else, for example, backup administrator or some other administrator of different roles, not an IIS role, will have access to our server, he can grab the credentials. Yeah. Actually, for this to work, he just needs to use the built-in tools, not, let's say, security research or compiled tools, because Windows gives us this opportunity to extract it by using built-in tools. This is in Windows System 32. inet srv config, actual configuration file is there. We can inspect this like this, for example, and we can see that there should be something like here. Yep, this is the line that tells that the IIS configuration that tells us that this particular pool is using this identity with this password. This password is, of course, encrypted here. So it's good to have it encrypted in the configuration file, but is it really not accessible for us? If it's encrypted, it should be reversible, because someone's service of the reconfiguration needs to have access for this password to actually use it, yeah? And for that, we can use the built-in tool that is in this folder. It's called appcmd. It has a lot of different parameters. But one of the most important for us in this case is this application pool. So we will be listing application pool named default pool. This was default application pool. Yeah. And most important thing is that we want to have the credentials in clear text. So if we inspect the output from this tool, we would find, here we will find that the RobShift has this password. Again, the same password, again, in clear text. Is it something wrong with that configuration? Of course not. It's a good thing to have the knowledge that we have the services that have, let's say, not the faults, but weaknesses that can be compromised by people with too high privileges in our system. Yeah. One thing to remember is that password hash is stored only in a Active Directory database or another database that is used to authenticate us, and we are using actually hashes only for authentication process, but for every other purpose the passwords are stored in one or another reversible way. So we need to have a unique account, unique passwords, and preferably the identity, the account should be restricted only for that service, only for the particular job that the service will need to do in our system. If someone will just grab the password as this way, then he will not be able to escalate or do something more about it. Yeah. And now we can think about something more useful that is also very excited for me. Actually, I want to inform you maybe that in our company we are growing constantly. Recently, there is a new guy. It's called Michal Grafneter. I'm not sure if you are aware that he wrote a DS internals. DS internals is a set of PowerShell tools that can be used to manipulate Active Directory. Yeah? So what can we do with our Active Directory actually? So one thing that I can imagine, if I have access to the Active Directory itself or the full database, is to grab the hashes and try to break them, try to crack them, yeah, or try to compare the hashes, because by comparing the hashes, I can see that one or more accounts are using the same password. Yeah. This is something very useful in penetration tests to just extract the whole database of Active Directory if it's possible. How it's possible? So the simplest way would be just to grab a shadow copy, and from the shadow copy we need two files, actually ntds.dit. The first file is actually database itself, and the second is a system hive from the registry. Yeah? So in the system hive we have the boot key. The boot key is used to encrypt the database, so we need two files, system hive and ntds.dit, to have the ability to extract the hashes from the Active Directory controllers, doing this offline or on another machine. But DS internals, the PowerShell tool, can do it for us even, let's say, better, and with a little help of built-in tools in Windows, we can create a running copy or offline copy of our running directory controller of these two files. I will show you how to do it. we will be using something that is used for recovery process. So for this, the tool calls NTDS util. Yeah, NTDS util. This is something from the knowledge base of Microsoft. You need to learn actually 3 commands. Activate instance NTDS, then IFM, and then create sysvol full. And let's say test. And right now we are creating the living copy of our important files. So this is the registry, system hive, yeah? And here we have ntds.dit. These 2 files are very crucial for us to use against, or not against, to use to extract the hashes. So let me run command prompt again, PowerShell, and now it's time to use DS internals. Actually, DS internals can be installed by multiple different ways. Let's say easiest way would be to just use the built-in install module command, ds internals. I have already installed this software. It will take some time to download and install it, so I will not run it, but this is full command needed to have the ds internals on your workstation. So now, as I said, we need to have boot key from system hive and ntds.dit file to grab the hashes, yeah? So let's use the ds internals for that matter. We will assign variable for this boot key, get boot key, yeah, system hive path, and I'm having this here, let's say administrator desktop system. Yep. Okay, we can see that this is something like this. We have also created tool ready to extract this information, but if we have PowerShell, every system actually right now has PowerShell, so why not use PowerShell for that? And the most important thing is this, get ADDB account. We want all accounts from database path that is users administrator desktop ntds.dit, yeah, and the boot key is this. Oops. Takes some time, but you can see that the hashes are flowing around, yeah? We can use slightly modified version, format, custom, view. It was called hashcat nt, I suppose. I'm not sure. Oh, yeah, this is it. Dash, yeah. Hashcat and let me check. Here is also. So this is ready for Hashcat. Hashcat, the cracking software for checking if it's crackable or maybe We have our own rainbow tables available for us for checking if the passwords are good enough, uncrackable, or are not, let's say, stored in some leaked database, like the Troy Hunt's Have I Been Pwned or something. Yeah, that was the site's name, Have I Been Pwned by Troy Hunt. So we can check against these databases if our passwords are unique and no one else is knowing them. Maybe they are too easy or too simple and already leaked by some different service. Yeah? For example, if we reuse the same password on LinkedIn, Facebook, etc., if one of this service has problem and they have leaked their passwords, then our password, for example, for ID is also compromised. Yeah. So this is, let's say, the first impressive for the penetration tester thing to note, that we are lazy. Yeah? We are people, and we always want to have same passwords or simple passwords because we want to just remember them. Yeah, I can count, let's say, 30, maybe 50 different services that I'm using constantly every day. If I should have unique passwords for them, I have. Yeah, but if I should have unique passwords for them and remembering them by heart, it would be very, very tough for me. And I am an IT guy. I should know how to do it. Yeah. Imagine the situation when the non-IT users needs to have the same amount of passwords. Yeah. So the solution for that would be just to use some cryptographically correctly implemented password storage, like KeePass example. And awareness program for users, that they shouldn't reuse the same passwords. The third most important thing to just have me excited as a penetration tester is that I have almost every time faced the situation that the big company is too big actually to use proper segmentation. In Poland, I have been doing penetration tests for one of the companies that actually convinced that they don't want to use segmentation, VLANs. They want to have one big network, and this network was something like 16 bits mask, so this was a huge network. Imagine the situation when this huge network consisting of all the workstations, printers or servers, they were connected on this, let's say, same cable, yeah? And I asked them, why? Why are you doing this? Why are you using only one subnet for everything? And they told me that they don't want to overcomplicate the network. They don't want to have smart switches, VLANs. They don't want to have different policies and rules on the firewalls. They want to have the network just running, working, and forget it. Yeah. So I was like, okay, that's your network. You are responsible for it. No problem. If this works for you, I can count days when you will be just crying about it. And maybe 2 months later, they bought some appliance, security appliance like proxy or something, and called my company shouting that the appliance just disabled all the network. Yeah? If they are connecting it to the network, then whole network is down. Okay, I said, why? We are not in the, let's say, times when switches cannot handle the new devices or something. Yeah, so this was very interesting because from the perspective of the network, I just reminded myself that okay, they are using the one big subnet, so this could be the case. So it actually was the case because the spanning tree protocol. There was no rapid spanning tree because, again, they don't want to change anything on the network, so they just used the, let's say, first version, the slowest spanning tree protocol. And after connecting new device, there was a topology remapping on the switches, and whole network went down. On top of that, we just show them that they have a big broadcast domain, and every time we just create the broadcast packet, the packet just is forwarded to every station. So let's say attacks, all the attacks like ARP spoofing are working smoothly for all the network. Yeah, after couple of months of changing, redesigning, and implementing new approach, they have subnets. Yeah, they have created VLANs, rules on the firewalls. I'm not sure if they are happy, but I'm sure that this is better than no segmentation. Yeah, so this is the third most exciting thing that I can face during the penetration test. Yeah. Next thing would be something like lack of SMB signing. SMB signing is a feature that some time ago was implemented and was disabled by default. Actually, right now it's enabled only on Active Directory controllers. Just to be safe that the policies are, let's say, correctly and without any modification downloaded for the workstations. Because someone said that, okay, SMB signing, enabling it will be a problem, a performance problem, because there is some cryptographic involved in that, and if every packet needs to be signed, then maybe the processor will be just overwhelmed, etc., etc. Right now we have tested it, and our computation power is big enough to just enable it on every devices, because without it we will be having problems, and I can show you which one or how the problems are visible from the perspective of the victim. Yeah. So for that we will be using Metasploit, of course. This is the easiest way to show something useful. And we will be using the Kali Linux as an attacking station for our Windows infrastructure. Yeah? As a side note, I would like to show you something that we have created in our labs, CQURE labs. We have created a very interesting tool to help us create not the undetected stealth payload from the Metasploit. It's called CQURE. What would be the name? Reverse shell generator again. Yeah. So it is very simple. It takes two parameters: IP address and the port of the listener on the of the Metasploit framework. Yeah, so it works like this. If the interpreter is our interpreter is on this IP, let's say we want to use this port. Bang! It's created, and this executable every time is different. Yeah, so I can generate it again and again. It will work as the vanilla reverse shell with Meterpreter, but it will have obfuscation and coding, packing, and different type of techniques to avoid antivirus software. And this way, it will be not detected by antivirus. So if we are doing actual penetration test and we are sure that MetaPreter or Metasploit will be our goal and we need to use it, then we are not using, let's say, Veil or other framework for obfuscation or for evasion of antiviruses, because sometimes these tools fail and maybe we don't have information about the vendor of the antivirus software. So this tool works perfectly every time and is not detected. And this is not a free tool. Let's say this is not a public tool. That's why it's not detected yet. Yeah. But for this purpose of this presentation, let me do this in a, let's say, proper manner. This is my Kali installation. I will run the console here. Okay. And prepare the second one. Yeah. So first, from the Metasploit framework, we will need to have a standard, let's say, exploit multi-handler. So all right. For this to work, we need to provide a payload. This will be the MetaPreter. Let's say bin TCP to be okay. The simplest one. This is our Kali Linux IP address. No, this is the attack victim IP address. This will be the, let's say, port here. All right, so it's ready. From the victim, from the attacking machine, also we need to use an attack to actually perform SMB relay. Impacket toolset. Impacket has a lot of different tools to manipulate the different protocols. One of the tools is called SMB Relay X. It's designed to prepare the SMB relay attack and execute. The X is the execute of our provided code or executable on the attacked workstation. Yeah. So we will use it. Relay X. Yeah. So this tool needs to have a couple of parameters. First is the host that we will be running this attack against. So this is our victim. Then the executable. So I will use the Veil in this time. I have already generated this payload, compiled payload, yeah. And it's ready, listening on different ports, ready to grab the credentials and use it against the victim. And because there is no SMB signing, the credentials can be reused. How is that? Maybe let me explain first the authentication mechanism on the NTLM protocol. If I'm the client and there is a server, yeah, Active Directory server, then the process can be explained this way. I have the need to authenticate for some service, let's say. So server has hash of my password. So the first thing the server says, okay, I will give you some data, blob of data, just encrypt it using hash of your password, and I will do the same on my side and compare it. So this is the simplest way. It's repeated on different services, different systems, not only Windows and NTLM protocol. So this is the simplest way to actually use the password, actually authenticate me against server that knows only my hash of my password without sending my password to the server. This is crucial. I'm not sending the password to the server, even if I'm trusting it, but I'm just using my hash. Server is using the hash stored on the database and comparing the results. Yeah. So the problem here is that the hash can be reusable. Then hash can be forwarded to other machine, and the other machine will think that it's legit and will authenticate me also. So if someone will steal the hash that I'm sending to the server, then this packet can be used against another server, and the other server will just trust it and say, okay, you are authenticated because everything is correct. I have done my comparison here. You are clear to go further. Yeah. So this is the case without SMB signing, of course. When we enable signing, then there is some small information added to the packet that confirms that actually I'm trying to talk with the particular machine, that I am talking to this machine, not the guy beside me, that the guy that stole my hash, someone else. Yeah, so the hash will be not reusable because it will be not signed. The signing will not be correctly. Here we have prepared our attacking workstation. Let's go to the victim. Yeah. We want to have a victim here as a normal account, so I will log out from this RobShift account and use this is a normal user. Oops. Okay. So as we can see, the normal user is doing his job. He has no special rights on this system, and we can confirm that, for example, there is no listener already listening. Find str. Yeah, there is no process that is listening on this port, on the port that we have defined for our Meterpreter bind TCP. Bind means that the Meterpreter will open the listening port on this particular attacked machine. Yeah, so we are clear to go. One thing to just to perform for us, the challenge for us in this scenario would be to convince someone with higher privileges to do something for us. This could be, let's say, IT service desk administrator. We will be calling him, asking him to just check something for us. Let's say we want him to check if some server in our network infrastructure is working correctly because we don't have, we cannot connect to it, but it should be available, something like this, the story. Yeah. So we are just convincing someone, the victim, to use SMB protocol for us. One thing to note is that the NTLM protocol will be used if we are authenticating against servers with short names or IP addresses. Yeah. So via phone, we just, for example, tell Rob, can you check if the file server that I can give you IP address is available for you because it went down suddenly, yeah? And Rob says, okay, give me the IP address of this file server, yeah? And actually Rob is typing this IP address that I'm just telling via phone, yeah? And that was everything that Rob done, yeah? But behind the scenes, as you can see, we have grabbed the Rob's hash, reuse it against our victim machine, and everything went down. So Rob tells us, okay, the file server is responding, but there is no file shares. Oh, thank you, I will call back after someone will, for example, fix the problem for me, yeah? Thank you, Rob. Rob is not, let's say, aware of this fact that his credentials actually were stolen, yeah? So this is the, let's say, most simple way in current enterprises to grab the credentials without even trying to initiate the attack of ARP spoofing. ARP spoofing can be spotted by the firewalls, IPSs installed on the VLAN. But SMB signing, lack of SMB signing, so SMB relaying attack, it's not always spotted. If you use ATP from Microsoft, you can do it. You can, of course, enable it by default. I encourage you to just do something even better. Migrate to Kerberos fully. If some systems are not available for the Kerberos, they are, let's say, legacy systems or not supporting this protocol, then put these systems on another segment, another VLAN, just to have these separated from your core network. This would be the better way. Of course, enabling SMB signing is the simplest way, of course, for that, but there are some nodes for compatibility, and issues sometimes arise, so be careful with that. You need to be aware that this is a simple attack for preparation and simple attack for grabbing credentials. The credentials for administrators are the most crucial ones, so these should be protected, yeah? Another... 10
more minutes.
Okay, let me be faster. So another excitement for penetration tester is the code execution. As you can see on the slide, there are executables, exe, DLL, lots of different extensions that have the potential of executing the code. Of course, we are just allowing them or disallowing sometimes using AppLocker, for example, rules. But most important is that we cannot do this, for example, for Office documents, yeah? So we need to be aware that sometimes the code can be hidden. There is a very interesting story about lol bins, yeah? So this is the list of different vectors using different signed by Microsoft, this implemented already in the operating system executables that can be used to download or execute some code for us. The code can be provided not only in an executable format, but also as a script or some kind of string that can be compiled on the station. So this is the fifth way that makes me excited. So sixth point would be whitelisting. So if we are not aware of what's important for us in our infrastructure, then actually finding the victim, finding the process that can be used for hackers, by hackers, is a very easy way. Yeah. So this is something that we also face every time, that clients don't use AppLocker's whitelisting approach, and they just restrict privileges maybe, but for unrestricted users, there is a way also to elevate themselves if they are allowed to run custom code or run different executables. Yeah? Old protocols and the defaults. Yeah, old protocols, of course, like for example SSL first version. Have you ever heard about it? I think no, because the SSL version 1 actually didn't have the premiere because it was so crappy that Netscape, the company that invented SSL, didn't want it to be publicly available. So right now we have TLS, and for this purpose, this is constantly used by browsers and other services. Yeah, so these are the protocols changing every time, and we have right now see that there are many different type of problems here. So old protocols and default settings. Lazy administrators, I'm lazy too, and if I'm installing, for example, something new, I just grab the installer, next, and then I want the software, this tool, just work. But how many times do we just stepping back and reviewing the configuration, changing it? For example, to review that the default settings provided by the vendor are best for us and secure. Yeah, sometimes they are best for the application because application just works. Yeah, but from the security perspective, they are not the best. Next example, trusting solutions without knowing how to break them. I can show you this example, but I'm not sure if we have time. 3 minutes. This is the, let's say, case when we are trusting, in this example, Sysmon. Sysmon is a great tool, believe me. Yeah? I'm using it every day, and it's a great tool for grabbing good events, extracting from the big amount of events the ones that are the most important for us. But the Sysmon has this feature or this ability. Every process that uses mini filters in Windows, that we can disable the mini filters. Mini filters are the small part that is running in the kernel mode and communicating with the service to give the information for the service that is only available for the kernel. So this mini filter for Sysmon is giving events, yeah, or grabbing process names, port numbers, and network IP information for the processes that are communicating via network. So we can disable these filters without disabling the service, and the service will not notice this. So this is another example of the lack of knowledge. Yeah, so we need to be aware that the Sysmon, for example, in this particular case, has this type of, let's say, flaw, issue, not a problem, it's an issue, and someone with the high privileges can disable it. So the same situation is in antiviruses. When antivirus software is not having something like watchdog service, then it can be disabled, and antivirus will not notify the command and control of the antivirus. So the server, the centralized server from the antivirus software will not notify that the service went down. Yeah. Next excitement, yeah, is by misusing the service accounts and using privileged accounts. We were using system accounts, but there is one privilege, SE debug privilege that can be used, and it's not default applied for the system account, but this small flag, this small privilege gives us even more power. I'm not sure if you know the Mimikatz, but Mimikatz is one of the very popular software used to extract passwords from the memory of the process. So to Mimikatz to work correctly, this privilege should be applied for Mimikatz. If we will monitor usage of this kind of privileges, high privileges, then we can limit the use of Mimikatz or something like that tools. Yeah, so we will be having, let's say, more restricted environment for our services. Yeah. Lastly, but not the end of this story, but for today, this is the last excitement. Falling for hipster tools. How many of you are using, let's say, 7-zip? This is very common situation. We always ask about 7-zip one thing. Do you know who is the author of the 7-zip? What company or maybe the individual? Is it trustworthy? Or do we have full confidence that this author would not change the software in this way that will the 7-zip will not do what it's meant to do? Yeah. So always we need to ask ourselves if we are using which software and if we are trusting this software. Maybe we need to review it, maybe we need to check if the software is actually doing what it's meant to do. And one another thing, 7-zip, Notepad, they, for example, are, I'm not sure if there is a use case for them to use a network connectivity. So again, we need to have a list which software is using network, which is not, because if something bad happens from the 7-zip Notepad or another process, then with a restriction for the network, we can be sure that the malware will not leave our workstation. It will possibly break one computer only, and I wish this will never happen, but the conclusion is that we need to always be aware of one thing. We will not catch with the bad guys. Yeah, this is the race between white hats, black hats, between criminals and cybersecurity guys. And this race will never end, but we can be prepared for that. We can be proactive. We can have full trace of what happened, if happened, because the if is like something like it will happen sooner or later. Yeah. So as an ending note, I would suggest having these 10 issues compiled into one. Just do everything you can do on your infrastructure and repeat this process. Check it. Every time you do something better, just go back, redesign, rethink, and check and implement again. This is the never-ending story, but this gives us a small advantage over cyber criminals. Thank you very much.
Thank you, Tom. Okay, do we have questions in the audience? Now, there was a lot of code typing. There was a lot of comments. Some people maybe did that. Some people do that on a daily basis, and some of us saw that first time. It happens. It happens. We understand the payload is etc. At least me, but nevertheless. Okay, since there are no questions, I will ask you a slightly different one. Can you give tips or your view on password management practices?
Oh, this is my favorite one, because actually, if you will have a good eye, I have this small thing. I'm not a vendor or some salesman from this small thing that I have here. I'm using KeePass. As you can know, CQURE have, let's say, reverse engineered the API from the Windows. If you are using KeePass and Windows integration, then there are problems that can be revealed for that, yeah? But if you are using KeePass and local password, plus you are using the second factor here, physical second factor, if I just grab the device and just have it with me, I can leave my computer here. I can give you a password for my KeePass because the rest of the password, the second factor, is here. And I'm pretty sure that it's unbreakable for the time. Yeah? It's right now unbreakable. Maybe in the 5 minutes it will be breaked. So my advice is use some storage manager and unique big passwords. I have my bank account passwords like 60 characters. So if I will lose the computer with the KeePass, the backup, and this device with the backup, yeah, then probably I will need to go to my bank to ask them to reset my credentials, yeah. But I'm pretty sure that my credentials are uncrackable, unique, and I didn't use it twice for different service. So I'm using constantly 30, 50 maybe services, but I'm just remembering one password for
yeah,
the
but
password
this
manager,
is what to do in a case you're not to trust that one single machine. I mean, I will help you with the water. Oh, sorry.
Yeah, go ahead.
It's done.
I have a backup in cloud. Yeah, I'm trusting the cloud solutions in that.
So you're backing up now.
Yeah, so that's why I have this one, and the second one is in my home in Poland. The backup of physical security, yeah. I have a backup of this database with passwords, and the first part of the password for the KeePass is in my head, so I think it's backed.
Okay, good one, good one. Thank you very much.
Thank you.
Nice applause. And here's a nice little
Thank you very
present
much.
and nice little certificate for you.
Great.
Thank you for coming. Thank you for your time.
Thank you very much.